Good morning, good day. Welcome to the Service Mesh Academy. My name is
Good
Phil
appropriate
Henderson.
time of day.
Yeah, good appropriate time of day. Or how in the Truman Show, Jim Carrey say, good morning, good afternoon, and good night if I don't see you. So, well, welcome to everyone. Today in this Service Mesh Academy, we'll be talking about anti-complex multi-cluster with federated services. And it's an exciting topic.
Hopefully.
Phil
is one of our customer success folks. So I'm Flynn. I'm a tech evangelist for Linkerd. I have the easy job of figuring out how things work and explaining it to people. And then Phil has the hard job of actually making customers happy. So happy that Phil's been able to join us. We are going to take a couple of minutes here just to give folks a chance to show up if they haven't yet. If you are here and you want to toss where you're from into the chat on whatever platform you're watching us on, or in the workshops channel on the Linkerd Slack, feel free. I think we have, yes. If I can find my mouse, there we go. The workshop channel on the Linkerd community Slack. But in the meantime, let's go ahead and get this rolling, shall we?
We shall.
So, federated services is what we're here to talk about today. Next month, we'll be talking about managing cloud costs with Hazel. You can register for that if you want. We'll have more to say about that at the end of this Service Mesh Academy. This one is all about federated services. We're going to start by talking about normal Kubernetes services, because normal Kubernetes services are not very well understood in a lot of ways. Then we'll go into federated services and why you should care. Then we have a demo. And then, as always, in Service Mesh Academy, we will talk about the gotchas. There are only a couple, but they're important to know about. If you want to follow along, and we hope you do, then that's a QR code that will take you directly to the source code for this specific Service Mesh Academy. That's the GitHub link up there at the top. I will be using, I don't know what the word need is doing on that slide. I will be using Buoyant Enterprise for Linkerd 2.18.2. You're certainly welcome to try that. We hope you will. It's free to try. If you don't want to, you can use Linkerd Edge 25.4.4 or later, and everything should work fine with that. I'll also be using a pair of kind clusters. The main requirement here, in addition to load balancer services, is that direct pod-to-pod networking between the clusters has to work. So a pod in one cluster has to be able to make a TCP connection directly to a pod in the other cluster. That is important. There's a script in the sources called setupbase.sh, which can set this up for you using kind and a Python script in the same directory, if you do not happen to have this lying around. Okay.
Most important thing to note about that setup is those pod siders and those service siders are all unique per cluster.
There's a reason why there's a Python script to manage that, because writing shell to get the siders correct just was awful. Yeah, that's an excellent point, Phil. If you have overlapping service siders or pod siders, things will not work, and they will not work in fascinating and subtle ways, although I believe Linkerd check will warn you about that. I hope Linkerd check will warn you about that. I should test that
Possibly.
after we're done here.
Yeah.
If you do want to follow along, you will need kind. You will need kube control. You will need the Linkerd CLI, obviously. You'll need bat if you want to run the shell scripts that I have. You'll also need JQ, and I'm pretty sure you need YQ in there, as well as Python and the shell and all that good stuff. All right. Any questions so far, Phil? Making sense?
Crystal clear to me.
Excellent. So let's talk a little bit about Kubernetes services. Actually, since Phil is here and it's his first time, let's put Phil on the spot. Hey, Phil, what is a Kubernetes service? I want one sentence, brief, to the point, and correct.
Oh man, a Kubernetes service allows you to connect multiple pods using service labels and makes it seamless for the end user to be able to do that. So you can scale up your pods and deployments as long as you have the right labels. your traffic should go to those particular pods.
Okay, so that was probably a run-on sentence, but I'll take it. Nicely done, especially cold with no warning. If you boil all of that down from a very high level, a Kubernetes service, we kind of intuitively think of them as a rendezvous. You have a workload that offers some functionality on the network. You have some clients that want to use that functionality. The point of a service is to give the client something that it can use to interact with the workload, right? That bit about rendezvous point turns out to be really useful. There are a bunch of other ways we could do this. All of them are really awful. The fascinating thing about service is that making that simple functionality work turns out to be arguably the worst, most overloaded, most confusing API in all of Kubernetes. What's deeply fascinating to me is that everybody who works on Kubernetes at a low level believes that, and nobody has been able to come up with a good way to do something better, because service is both so entrenched and because the things it does are so critical. So it's a fascinating problem to look at. The reason it's so bad is that every service has at least 5 different functions. I say at least 5 because depending on who you talk to, people will actually add more onto this for particular edge cases. But they always have at least these 5. Number 1, the service has a name, which lets us humans refer to it. We like names. We're not terribly good with numbers. Number 2, that name gets put into the cluster's DNS so that the client can look up the service using that human readable name and find the rendezvous point. Number 3, the service itself gets an IP address. This is actually an interesting one. You could do this so that the service did not have an IP address and instead all of the endpoints did. That's basically what Kubernetes calls a headless service. It has some really fascinating behaviors, which in many cases are not what you want. So in most cases, you will get an IP address with your service. That will be the address in the DNS for your service. And a client that wants to talk to your service will talk to that IP address. That means that service has 2 other jobs it has to do. The first one is, remember, we're probably going to have multiple replicas of our workload, multiple pods, each of which will have an IP address. Phil was mentioning this earlier. The service matches up those pods using label selectors. So the service has to collect all of those IP addresses and store them someplace, either in an endpoints resource, yes, an endpoints plural resource, terribly named thing, or in one or more endpoint slices. There, the resource name is endpoint slice because Kubernetes is nothing if not consistent. So it collects all those and it crams them into other resources so that other things can find them and then use the IP address of the service and all of the endpoints to configure kubeproxy so that when the client actually speaks to the service's IP address, it gets relayed to one of the workloads. Important point, if you're using a mesh, kubeproxy is not involved and the mesh takes. So 5 different functions at least. And most of these span span different areas. They're not all in the same place. Having a name is mostly just normal Kubernetes resource stuff. The name of the service appearing in the cluster's DNS means that we have to have an interface between the service and the DNS implementation. If you go looking for this code, it's kind of fascinating to even try to find it and figure out how it works. The service itself gets an IP address, which means that service has to interact with IP address management, which is a huge part of Kubernetes clusters, albeit mostly an invisible part. Collecting the IP addresses of all the workload replicas, depending on who you talk to, is either IPAM or more resource stuff. And the most fascinating thing about this is that what actually does it in Kubernetes is a thing called the endpoint controller. And you can't replace the endpoint controller and you can't turn it off. That might be changing in some beta of Kubernetes coming up soon. I hope. Oh man, do I hope. But for right now, one of the really fascinating things about all this stuff with service is that it happens in ways you can't turn off, even if you want to. Finally, the service IP and its endpoints are used to configure kubeproxy. That is an interaction with the container networking interface, and it is also deeply, deeply fascinating. So, services are ugly. Ultimately, the concept is really simple, but making it work is really, really not simple. The good news is that if you're an application developer, you will often not have to worry about all this stuff. If you're using Gateway API for mesh, you do have to think about a little bit of it. You have to think about the fact that traffic being directed to the IP address of a service is not the same as traffic being directed to an endpoint that backs that service. But that's usually the worst for an application developer. On the other hand, if you're implementing Kubernetes networking stuff, you're going to be living and breathing this stuff all day long. So the people working on Linkerd or Istio or Cilium or any service mesh, this is a huge factor. Those of us working with Gateway API argue constantly about all of this stuff. If you're writing an Ingress controller, this is a big deal. Just all that stuff, it gets to be really ugly. Okay. We didn't say it before. Well, we kind of did say it before, but to reiterate, if you have questions, tossing them in the workshops channel on the Linkerd Slack is a great place to do it. And I thought of that just now because I figure folks might have questions about this. Anything come to your mind, Phil, before we get on to federated services?
Nothing on the top of my head at the moment.
Cool. Actually, it occurs to me one other thing I meant to point out here is that kubeproxy turns out to be a really fascinatingly misnamed thing. It is not actually a proxy. All kubeproxy is just changing IP tables. So it is one of the more misnamed chunks of Kubernetes. I'm not going to tell anybody how long I'd worked with Kubernetes before I fully understood that, because that would be embarrassing. Okay, federated services. Federated services are simpler to talk about than Kubernetes services. So here is what we've been describing with Kubernetes services. You've got a service called my service. It's got a bunch of workloads that it's fronting, and you send stuff to my service and it gets funneled out to your different workloads. A federated service is fundamentally the same thing, just suppose all your workloads don't have to be in the same cluster. They might be. One thing this diagram is not great at is that it implies that the service must be in its own cluster. That's not true. The service could be in with any of these. But federated services are pretty much all about, let's take a service and let's arrange it so that those endpoints don't have to be in the same cluster. For discovery, federated services rely on having a service in each cluster as well. You end up marking that service to say, hey, I want this to be part of a federated service, in much the same way you can mark one with Linkerd for being a mirrored service. And then the federated service will go and look to all of those, collect information about their endpoints, and populate them into endpoints in that service at the very top. This relies on a concept called namespace sameness. If you have that service called my service, and it's in a namespace called myNS, then every other service that you want to be a member of the federated service must be named my service, and it must live in a namespace called myNS. If you change the name of one of them, then it will not be discovered as a member of the federated service. If you change the name of the namespace, it will also not be discovered as a member of the federated service. I have seen this burn people, although it's usually something that's not a big deal because it's usually the way people set up Multicluster. This concept actually is one that we got from the Multicluster Service Working Group, where the semantics of multiple clusters are usually that each of your clusters is sort of semantically the same. Every service, if you have a bunch of my services in all of these clusters, the expectation is that, like replicas in a single cluster, they would all have the same job and they would all do the same thing. Same thing with namespaces. If you have a namespace called, I don't know, banking in your multiple clusters that are all chained together, it's a reasonable assumption that you intend for the banking namespace to have the same job across all of your clusters. So we lean into that with federated services. One other thing I want to point out here, discovery involves the federated service going to all of the member services, going to all that multiple step thing. Routing is different. Routing goes directly to the endpoints in the remote clusters. This is why you have to have pod-to-pod networking enabled. But it also means that routing gets to be really fast and really seamless, which is kind of nice. All right, what do you think I missed, Phil?
Nothing yet. Nothing that's catching me.
That always worries me.
Almost too simple, but hey, that's the Linkerd way. It just
Yeah,
makes
yeah,
sense.
kinda.
It works.
That's the idea. All right, so let's talk a little bit about the demo architecture here. I was telling Phil earlier, we might actually do a short SMA today because federated services really are pretty easy to talk about. It's kind of nice. Demo architecture. We will be using the world famous phases demo, which can look like this. That's the QR code that will take you to the GitHub URL for phases, should you be so inclined. Phases works by, we've got the GUI. Wow, sorry, I need to remember how to turn off the names, and I'm not going to go look that up right now. Anyway, we have a Faces GUI. The GUI running in the browser talks to a workload in the cluster named Faces GUI. Faces GUI is pretending to be an Ingress controller as well. Don't actually do this in the real world. In the real world, you should use a real Ingress controller. For demo purposes, we're going to keep this lightweight and not bother. So the Faces GUI workload talks to a workload called Face, which uses HTTP to talk to Smiley, which uses gRPC to talk to Color. Smiley is supposed to return a grinning face smiley. Color is supposed to return this blue color. Face composites the two together, and that's what the browser shows. For every cell in the browser, you get a separate call happening to face and thus to smiley and thus to color. All right. Time for the demo. Everybody cross your fingers. You know, as always. Okay, so as I mentioned before, I have a couple of kind clusters running here. They are named East and West in a fit of originality. I also have kube control contexts set up, so I can refer to those as --context east and --context west whenever I run a kube control command. The fact that we're using kind for this is mostly irrelevant. Originally, I did it because I thought I was going to demo stuff for which I needed 2 load balancer services in each cluster, and K3D is bad at that. So I used kind, which kind and MetalLB handles that very nicely. I ended up not doing that, so I could have done this with K3D, but whatever. It was already set up to use kind, so it's no big deal. Actually, 2 big caveats. The first paragraph mentions we have a flat network between the 2 clusters so that pods in one cluster can talk directly to pods in another cluster. That is critical. If you don't have that, this demo is not going to work. Another part of this demo is, sadly, it will not work unaltered if you are using Docker Desktop on a Mac, because Docker Desktop on a Mac does some very weird things with networking between the Macintosh and the Docker containers. If you're on a Mac, use OrbStack. It's much more clean about stuff like that. All right. Both of our clusters, we started off with Linkerd installed because I really didn't want to take the time to make everybody watch installing Linkerd. It's pretty much just installing Linkerd.
Even though it's quick and simple, right? It would have taken.
Well, I mean, it's fairly quick and simple, but when you're also doing multi-cluster stuff, you force everybody to walk through all the certificate management and all this stuff, and it's just like,
it's not as exciting as the actual demo.
Yeah, if you want to know how to install Linkerd for this demo, look at the scripting that installs Linkerd for this demo. In all seriousness, it really is. We set up a trust anchor. We set up an identity issuer for each certificate. We install Gateway API and the Linkerd CRDs and Linkerd on each cluster, pointing the Linkerds at the certificates for their cluster. And that's it at this point. We haven't done anything else yet. Okay. Next thing we're going to do is we're going to install Faces, because that way we have something to look at. We're going to create a faces namespace in our east cluster. We're going to annotate that for Linkerd injection, and then we're going to use Helm to install faces. I am not showing the contents of that values file. It basically says, turn off all of the screaming errors that faces normally has, because we don't really need them at this point. So this is going to take a second or two, probably. Invariably, I find that when I install things, it takes just long enough for me to be concerned that it's not working. Okay, it's working.
I was blaming the ISP for having to download the Docker images. So
yeah, exactly. That's it. We're going to do exactly the same thing in the West cluster. Like exactly the same thing. The only difference in these lines is changing the word east to the word west. While we're waiting on that, there we go. Okay, so we can grab the load balancer IP of the faces GUI service in each of our clusters. That is a fairly ugly command that is, we're going to get the service. Where's my mouse? We're going to get the faces GUI service in the faces namespace, and we're going to look in its status stanza for the first IP address of the ingress in the load balancer stanza. One of them is at 192.168.155.16, exactly the same thing for the West cluster. And that one is at 155.32. And if we flip over to a browser, this is 192.168.155.16. That's our East cluster. I have another tab here for the West cluster. And you can see that the difference is that in the East cluster, we have grinning smileys on a blue background. We've configured the West cluster to be hard-eyed smileys on a green background. Very exciting, I know. All right. So we can also prove that our clusters have a working Gateway API installation. It's a little tricky to see which one is which, but I just switched from the East to the West cluster to the East cluster. That is the same web browser I just showed you overlaid onto my window right now. So in the East cluster, we are going to apply a route, a Gateway API HTTP route. Since Face talks to Smiley using HTTP, we're going to take all the traffic to the service named Smiley on port 80, and we're going to summarily redirect it to the service called Smiley2. If we do this in our East cluster, we will suddenly get a bunch of meh faces. If we delete it, we get the grinning faces coming back. So, yay, Gateway API works. How exciting. We can do exactly the same thing with the West cluster, again, to prove that it works. This is the same route. We're going to redirect traffic to Smiley 2, but in the West cluster, Smiley 2 is a rolling eyes smiley. All right. And we could do the same thing with color and all that stuff, which would be great, but we're not going to bother. Okay. This works. It's kind of uninteresting because this is just the usual Faces app running in a cluster, and yay, So it's time to get multi-cluster going. We're going to do this in a way that is a little different from what we have done sometimes in the past. And actually, as I'm about to go through this long period of talking instead of showing stuff, once again, now is a great time to throw in questions if you have any.
We did have one question if we were going to walk through Gateway API and how it relates to services, ingress, and federated services. So this is a nice segue into that, I believe.
Yeah, we actually did a Gateway API 101 SMA, I want to say a couple months ago. So for more detail on Gateway API, I would strongly encourage going back to that. But we will, in fact, be showing off Gateway API and federated services. So you'll see more of that later on in this demo. I mean, yeah. Okay, so the way we're going to install multi-cluster here We're going to install the multi-cluster extension in both of our clusters. Excellent. That will arrange it so that we can mirror services and we can have federated services and good things will happen. We will generate the link resources that we could use to link our clusters together, but we're not going to apply them yet. This is a big change in 2.18, right? Big change in 2.18, GetOps friendly multi-cluster. So it used to be that when you would basically, the multi-cluster link command, you had to apply the resources right then. It contained a bunch of things about the link, but it also contained a bunch of crap about the controllers that kept the services mirrored. This did not work well with GetOps. Things are better now. We'll talk a little bit about that in a moment. So we're going to generate the link resources, but we're going to leave the clusters unlinked. We're then going to set up the federated services at that point. Then we'll set up faces so that it gets to use the federated services, even though the clusters aren't linked yet. And then finally, we'll apply the generated link resources, which will link the clusters and allow traffic to flow between them. There are two main reasons to do things in this order. One of them is that we get to show off GetOps friendly multi-cluster, even though we're not going to demo GetOps in this one. The other one is it lets us verify that the application is doing the right thing with federated services before we start messing around with debugging whether the clusters can really talk to each other pod to pod. So the old way of doing multi-cluster, I am not going to lie. There were several points where I would get mired in trying to debug something where I wasn't sure if my application was correct or, if was my application correct and the links were broken, or were the links correct and my application was broken, and trying to deal with both of those at the same time is just not a lot of fun. So separating them works out better, at least in my opinion. Okay. So let's start by installing the multi-cluster extension. Things are slightly different here with 2.18. The biggest difference is that when you run Linkerd multi-cluster install, you actually have to tell it which clusters you're going to link to later. I'm not a huge fan of this, and I understand that the idea is to make this simpler in later releases, but for right now, this is the way it's done. And then, as we mentioned, we'll use multi-cluster link gen rather than multi-cluster link. So in the East context, actually, I take it back. I almost got ahead of myself. The first thing we're going to do is we're going to make sure that both of these clusters really have the same trust anchor. This is another one of those ugly commands. So there is a config map in the Linkerd namespace named Linkerd Identity Trust Roots. It contains a certificate bundle of all of the certificates that are considered valid as trust anchors, the root of trust. It's basically, this is the set of certificates that Linkerd is allowed to use for signing purposes. So if a workload, if a Linkerd proxy tries to connect to another Linkerd proxy, the certificate chain has to end at a trust anchor in this config map. If it doesn't, it will be rejected. There's a key in that config map, data.ca_bundle.crt. Unfortunately, the second dot is part of the key name, not a hierarchy separator, so we need the backslash. We're going to grab that with JSON path. We're going to feed that through step certificate inspect. Oh crap, I forgot to mention that you needed the step CLI for this. And then we're going to haul out the subject key ID from the extensions. When we do that, we will get a 16-digit hexadecimal value. That's the ID of the trust anchor in my East cluster because I ran this in my East context. Now I'm going to repeat exactly the same command except for the West context. And thankfully, I get exactly the same value. So we should be good to go. Assuming that the identity issuers do the right thing. And I could check those, but I'm not going to bother. Okay. Next up, we're going to supply a values file to multi-cluster install. It's actually possible to do this with a -- set on the command line, but I find that uglier than just having the values file here. So this is saying, hey, you need to set up the controllers to allow me to link to a cluster named West. Another crucial bit here, in addition to feeding in the values file, we're going to turn gateway. We're going to set gateway to false. That tells Linkerd multicluster install that we will be using flat network multicluster. We will not be using the sadly misnamed Linkerd gateways for multiclusters that you have to use if you can't do pod-to-pod networking. Federated services do not work if you don't have pod-to-pod networking. Hopefully that'll be another thing that we fix later. So we install that. We've got a bunch of stuff there. We do pretty much the same thing for the West cluster, except that this link is set up to link to East. And we are going to do, links are unidirectional. We're going to do both directions just for the fun of it. So we'll apply that in the West cluster. And then we're going to do a multi-cluster check in the East cluster, which is great. And a multi-cluster check in the West cluster, which is also great. So should be good to go to start federated services and later link the clusters. All right. Okay. Let's do a link generation here. So we just made the, actually, you know what? Let me call that out a little more explicitly. Pay close attention to the context and the names here. This is the East context. We're telling it it's for a cluster named East, and it's going to a file named eastlink.yaml. Then we've got the West cluster. For a cluster named West, it's going into westlink.yaml. If you mix those up later, very confusing things happen. Just for the fun of it, I'm going to use the old multicluster link command. You'll notice that these are multicluster link gen commands. And now we can take a look at what's in EastLink. Okay, so we've got a bunch of kubeconfig stuff, which I'd be really worried about if these clusters weren't running on my laptop. So we've got a secret, and we've got a secret in a different namespace, and then we have a link resource, and that's it. If we look at the old version, we have the secret and the other secret and the link resource, and then we go into a ton of RBAC and a deployment, and it's really much uglier. Please don't use multicluster link anymore. Use multicluster link gen. It really makes life better for you.
Yeah, and a lot more secure. I know this isn't more about the new multi-cluster feature, but now we just only require you to have the link resource, and you can place those kubeconfigs in a more secure manner on your clusters. So it's a much more GitOps friendly and secure way of providing these links to your clusters.
Well, it used to have
future SMA on that and dig into it, because it's interesting of why we did it that way as well.
Well, if you look back at the way multicluster link used to work, the fact that it had all the controllers bundled into the same thing meant that you had to rerun multicluster link every time you upgraded Linkerd, which means it would regenerate all the stuff, including the secrets, and it was just ugly.
Yes.
So these days, as Phil points out, the kubeconfig stuff isn't going to change unless you bounce your cluster or you rotate the cluster, like the API server's key. So you can write those into some sort of, secret storage or whatever, and then check the link resource in via GitOps, and it just works, and everything is much nicer.
Yeah, and that's much more natural to what customers and clients are doing anyway. So it just kind of fits into the security model, what people are adopting already.
Yeah, we haven't. It's been a long time since we've done an SMA on GitOps. We should probably do one of those again soon as well. But I will say, GitOps can be a little tricky to set up in the first place. But
yeah,
oh my God, seeing people who have set things up so that the only source of truth is the running cluster is terrifying. I can't even tell you how many times I've seen clusters crash, or, Phil actually had to deal with that just recently in his home lab, if I recall.
Yeah, I wiped up all my cluster API clusters with the wrong commit. Like, well, don't.
Yeah. I'm not going to tell people how long it's been since my home lab is running. I have not had bandwidth to go and bring it on new hardware. Okay. So now that we have the multi-cluster extension installed, we can do multi-cluster at all. We're now going to go through and turn up federated services. The way you tell a service that you want it to become a part of a federated service is with this label right here. You label a given service with mirror.linkerd.io/federated equals member. That's it. So we do that for Smiley in the East cluster. We do that for color in the East cluster. Then we do the same thing in the West cluster. Again, same command. I just literally changed the word East to West. And now if we look at the services in the East cluster in the faces namespace, we see that there is a color federated service and there is a Smiley federated service. Same thing in the West cluster. We can see that there is color federated and we can see that there is Smiley federated. We have not linked our clusters yet, which means that these federated services only have endpoints in their own cluster right now. There is a Linkerd diagnostics command, Linkerd diagnostics endpoints. And in this case, I can use that to take a look at what endpoints Linkerd believes are present for the Smiley federated services in the faces namespace, service.cluster.local. In the East context, East cluster, this command takes several seconds to run. It just does. Be aware. So you can go through this and you can see that we have a single endpoint. In the East context, you can see we have an endpoint that starts with 10.1, and then in the West context, you can see that we have one that starts in 10.2. We can we can verify that those things belong to their correct clusters by looking at the IP addresses of the various pods running in there. So looking at Smiley, for example, the East pod, its IP address is 10.1.1.16, which is exactly what we see for the endpoint of Smiley federated in the East cluster. In the West cluster, again, 10.2.1.13, same address for the endpoint in the West cluster. So that's why those numbers appear. They are considerably less magic than they seem. Basically, at this point, since we haven't linked the clusters, our federated services are just acting like normal services because they are services, which is great. Now, a bit of an interesting question here. When I set up the faces workload, I told it to talk from, when I set up the face workload in the faces demo, I told face that it should talk to Smiley and color by those names. So the fun question here is, and I really should have put in a wait so I could put Phil on the spot. Oh well. The fun question here is, how do you tell that that's really what's going on? The obvious answer is, oh, you just fire up Linkerd viz and you look at it. As it happens, that doesn't work because Linkerd viz will tell you what pod you are talking to, but it won't tell you what service you used to get there. We do have some new metrics that are much better at this, though. We have this outbound HTTP route backend requests total, which is a mouthful, but it is a gauge of the total number of requests that a given proxy is sending outbound using HTTP, and then there's another one for gRPC. So if we look at those metrics for our face workload, and we can get those with Linkerd diagnostics proxy metrics, then we should be able to see some useful things. What we're doing here is we're going to run proxy metrics in the faces namespace for the face deployment. Thankfully, Linkerd knows how to take a deployment, turn it into a pod, and get its proxy. Then we're going to grep for exactly the two metrics we want. Then we're going to grep out everything that isn't Smiley or color. And then finally, if you're familiar with Prometheus metrics, they end up having a lot of commas in them, and they're very long lines. So we're going to turn those commas into new lines and indentation. And when we do that, we get this horrible stuff. But you can see some interesting things going on in here, right? The parent name, Smiley, the parent port, 80. This is telling us the service to which the request was sent. We also have a backend name and a backend port. In this case, we see that at some point we were sending traffic to Smiley 2 on port 80. That's when we had the HTTP route redirecting from Smiley to Smiley 2. And we also have a route kind, HTTP route, and a route name, Smiley route, is the route that was doing that routing. This metric is still in the proxy because even though we're no longer doing that routing. And if we were to run this command multiple times, we would see that this number, the total number of requests, was not going up. We can also look up above and we see numbers that are much higher for like color, which is going to color, and for Smiley going to Smiley, implying that, oh, hey, those are the active ones. Doing this in shell is yet again kind of awful. The right way to do this is to go set up Grafana or something like that. We are not going to do that. We are in fact going to use a horrible Python script that runs Linkerd proxy metrics and then just parses some stuff out. And the reason we're not going to do this is that I don't like cluttering demos with Grafana and Prometheus and things like that. And I do kind of like to show off the fact that you can do, metrics are fundamentally, I mean, they're weird and they're noisy, but fundamentally it's just text processing, people. So if we fire this up, the green lines show up for a brand new backend that we've never seen before in this run of our crunch metric script. The gray ones are things that are no longer happening, where the number doesn't change. And for other ones, we're showing the number, in between samples. That's kind of all there is to it. So we see that color going to color is getting traffic, Smiley going to Smiley is getting traffic, and Smiley going to Smiley 2 is no longer getting traffic. So that's what we want to see. But there's an interesting thing here. Phil, do you happen to remember how face talks to color?
Face calls via gRPC.
Do you see gRPC in these metrics anymore?
I do not.
No, this is a problem because, colors traffic is gRPC, not HTTP. That's kind of our first gotcha here. This is not really a gotcha of federated services. This is just a thing to know about Linkerd. If you want really good gRPC metrics, you need to have a gRPC route in place. The reason for this is that there's not another way right now to tag something as being gRPC traffic other than using a gRPC route, because gRPC traffic looks like HTTP traffic. The only real difference at the protocol level is the trailers, and those metrics get generated before we have access to the trailers. So we need a route. We will add a total no-op route here. This is basically saying gRPC traffic going from color is going to go to color. But applying that in both clusters, it's the same in both clusters. Applying that will let Linkerd know, hey, this is gRPC traffic, and Linkerd will do good things. So if we run crunch service metrics again, now we see gRPC traffic happening to color. And we can see that the HTTP metric for color is no longer climbing. As an aside, the reason why those numbers are not all the same value depends on which window my browser tab that you can't see is showing, which I find really, really amusing. All right. I feel confident that Phil has things to add about metrics as well, because metrics are a brutal thing that show up
a lot of metrics lately, and observability is what I've been living and breathing a lot lately. So
yeah, it's kind of fascinating. We'll have more to say on metrics a little bit later in this demo. Okay, we are now going to switch the Faces app to use the federated services. We could do this with HTTP routes and gRPC routes, but in fact, we are not going to do that. We're going to switch the app to speak directly to the federated services, partly because we can, partly because I want to save gateway API and federated services for a little later in the demo. So if I set this environment variable and then I wait for that to finish, there you go. You'll notice that we didn't see anything in the demo application. It just kept running. All good. Honestly, we got a little bit lucky there because, it does have to change the deployment. So sometimes we can see gotchas. Over in the West cluster, same thing. And yeah, we got really lucky this time. So no errors. Great. All right. Now, if we run Crunchmetric services, then we see color federated and smiley federated. And we're back to seeing color federated as HTTP because our route only covered color, not color federated. So we can fix that with exactly the same kind of route. And we can go back, and now we will see gRPC traffic to color federated. So once again, wow, that's a funny bit of timing there. Once again, we're basically seeing that federated services just act like services, even down to how Linkerd treats them and gotchas around metrics and things like that. Okay, at this point, we have both clusters using federated services for color and for smiley, and our clusters are still not linked, so we should fix that. Pay careful attention to the contexts and the names in these next few commands. Here, I am applying to the West cluster a link that will let it talk to the East cluster. So actually, I guess I should probably go and show this one. And when I do that, you can start seeing a mix of multiple smileys because suddenly the endpoints for the East cluster appeared in the West cluster because that's the way services are supposed to work. A new set of pods became available, the endpoints update instantly. If I go back to my East cluster, it's all grinning smileys on blue, and when I apply the West link, I start seeing things coming in from the other cluster. You'll notice that these don't look necessarily very much the same. We're not necessarily getting really great load balancing behavior. That's candidly because the traffic here is so low. Linkerd's routing algorithms just don't have a lot to work with here, so we can see some kind of weird behaviors. Also, since they're mixed and matched at this point, you're just going to have to take my word for it. That's the East cluster showing right now. All right. If I now use Linkerd diagnostics endpoints to look at smiley federated, we see multiple endpoints. We see one from 10.1 and one from 10.2. If I repeat that in the West, then we will see, again, the same endpoints in there. Just they happen to be in the same direction. That doesn't always happen. Like in the same order, we don't always, sometimes one will have 10.1 first and 10.2 second.
You got a 50-50 shot there, so.
Pretty much, yeah. And obviously, if you have more than two clusters, all of this works exactly the same way. It's, you're just going to see more endpoints, you're going to have more links, all that. The other fun thing that we can do here is, suppose we just scale the color workload in the East cluster down to 0. We do that, and now instantly everything is green because the blue color workload just vanished from our federated service, which is, again, exactly what we want. And now we're just up there to seeing that both of our clusters only have the 10.2 endpoint. I would really love to figure out how we can tweak diagnostics endpoints to be faster. Another fun thing we can do here with Smiley, if we scale the West cluster's Smiley workload down to 0, then we only get to see grinning faces. And that, again, happens really fast. One really fun point that we talked about a lot in the practical multi-cluster SMA is that this sort of capability actually makes it really easy to migrate things across clusters too. So at this point, I now don't have a Smiley workload running in my East cluster at all. And I can just have it running in West. If I want to spin up a North cluster and then bring up Smiley there, it's going to start taking some of the load. And I can do this, for example, maybe my North cluster is running a K3D cluster that still has network connectivity. So I can do migrations across cluster providers without thinking too hard about it, which is extremely cool.
I am currently like in the midst of like helping a customer go exactly through this, moving from one cloud provider to the next. They have a private link between them, and we're using essentially this mindset to start migrating from GKE to AWS. So it's exciting stuff of how we can, in a real world, leverage a lot of this stuff.
I am so going to talk to you about that, because I actually really want to know. I've had people ask, "Oh, how do you do this across real cloud providers?" And I've never known the answer.
It's possible. So yeah. I have some insight to it.
Yeah, cool.
And the guys doing it are like very smart guys. So
one would hope, yeah.
It's been a very fun, little project.
One thing that I wanted to show off that's not explicitly in here. So if you look up the IP address, if you can read it, this is my .16. That's my East cluster. If I go over to my West cluster, we see the IP address change, but we get exactly the same results because we only have one color workload and one Smiley workload now. They happen to not be running in the same cluster, but that's okay because the GUIs get to see them both in both directions. Okay, I said we were going to talk about metrics a little bit more. There's a really fascinating thing about the metrics right now, which is that we can see metrics talking about services. I showed those, but they don't show endpoints. So if I were to run current service metrics again, then it's just going to show me, oh yeah, I'm talking to Smiley Federated and Color Federated, and it won't tell me which specific endpoint got hit. Now, if we fired up Linkerd viz, that could show us some pod information. It's a little interesting because it wasn't really designed for multi-cluster stuff right now. And there is an older request total metric that has some endpoint data in it. But overall, this is a place where the metric story is a little trickier than I would like it to be right now. The big challenge is basically that if we start adding endpoints all over the place, then the cardinality of all the metrics skyrockets, and you end up with a nasty storage problem. So this is a tricky one. Feedback welcome. Let us know what you'd like to see here. Did you want to add anything else to that other than nodding that cardinality is the root of all evil?
I hear the word cardinality, and it's like one of those words I hear and it just makes me cringe. It's like, it's like a daily battle sometimes.
If you're not, I should have defined that actually. If you're not familiar with cardinality as it pertains to metrics, in the Prometheus model, you have a metric with a bunch of labels attached to it. But the more individual labels and values of individual labels you have, the more crap you have to store for the metric. So every time you add a label that could have multiple values, and remember, we're talking about endpoints, they could have hundreds or thousands of values in large clusters. And you can literally be multiplying your storage requirements for things like your outbound HTTP requests by a factor of 1,000 or 1,000,000. And that's a big problem. So a lot of what Linkerd tries to do right now is to keep the cardinality down. It's a thing we are very, very actively wrestling with. Okay.
And we're not alone in that either.
Yeah, everybody has that problem. That's not just a Linkerd thing. Yeah, that's a good point, actually.
I created a centralized Prometheus Grafana thing for all my clusters, and before I even put Linkerd in the MISC, I melted it down because of just trying to process too much. So
yeah.
And not having the right, labels for clusters and trying to overwrite metrics is just a mess.
Now, admittedly, both Phil and I for Home Labs are running on Raspberry Pis, so we're not talking about huge Prometheus engines here. But
I might be in an environment that's quite large, so I do have that guy.
Okay, well, I take it back then. You got the fancy stuff.
Yeah, it only has like a 4 terabyte of RAM in it.
Oh my God, that's insane. All right. So we had a question about Gateway API and cross-cluster routing and federated services. So let's get into that. What we're going to do here is we're going to use Gateway API to do some routing to make our GUI do different things depending on whether the request is coming for one of these cells in the center or one of these cells around the edge. And just for the fun of it, because I feel like a lot of our demo stuff uses HTTP, we're going to do this on the gRPC side of the world because, why not? What we're going to do is we're going to take the color federated traffic to the center cells and only the center cells, and we'll bounce them over to the color 2 workload, which will return yellow. Okay. We get to do this because the gRPC call from face to color uses a different gRPC method depending on whether it's a center cell or an edge cell. The methods are creatively named center and edge. So we're going to have this thing looking at traffic going to the color federated service in faces namespace. If the method matches the color, that was entertaining. I think I just accidentally turned off my screen share. Don't try this at home, kids. We are trained professionals. All right, let's try that again. Okay. The curse of dead air. Let's see something here.
I can see your browser. Now I can see your...
What you're not seeing is having them update. So if you'll give me a second, I will fix that.
While you're doing that, we had someone ask about some more use cases about like leveraging federated service besides like migrations. DR is another, popular way of like leveraging federated services, like Flynn's showing. You can have services running in one cluster and even just have them turn down to 0 replicas. You can have like a hot, cold type of mindset, even for DR. So there's another, use case out there as well that we have seen with customers, utilizing federated services, trying to have multiple clusters and having them ready when things start melting down, that they could just spin up services and add those endpoints instantly into the service like Flynn was showing.
And we now have the live demonstration of the advantage of multiple people on this stream where I can be fixing my setup while Phil is answering a question. Or hopefully fixing my setup. No. All right. You know what? I think we're going to do this the scary way.
Yeah, and as questions come in, keep posting them in chat and the Slack, and we'll answer them as we can.
All right. So what I was saying was traffic to the color federated service that matches the gRPC service of color service and the gRPC method of center will go to color 2, and anything else will hit this fallback case and continue on to color federated. Let's go ahead and do that. So I actually really, really hate doing things this way. All right, there's my running. We're doing this in the east cluster. I just hit return on the apply command, and we can see yellow over there, which is great, right? All right. Now, the big challenge here, though, is, okay, let's see if I can go back to the way I want this to be working. Okay. If we flip over and we take a look at the west cluster, nothing is happening. We still have just green, right? So this is the main gotcha of using Gateway API with any kind of cross-cluster routing, including federated services, which is that routing decisions happen exactly once for a request. And the routing decision is made where the request starts. This is also not just a Linkerd thing. This is for anybody doing Gateway API, because if you try to do anything else, you end up with a bunch of deeply, deeply disturbing possibilities, where the least problematic one is routing loops. So that is not a thing in Gateway API. Therefore, if we want to make the West cluster work as well, we're going to have to add the same gRPC route in the West cluster. I didn't change anything in here. This is exactly the same thing. So if we apply that, then we see red cells. Quick, Phil, why are these cells red instead of yellow?
Do you have another color workload running somewhere that's red?
Basically, yes. If we take a look at the crunch metrics here, you'll notice that we have gRPC traffic going to color 2 in both clusters. Color 2 is not a federated service. So we can have different color 2s in each of our clusters right now. As it happens, color 2 in East returns yellow and color 2 in West returns red, so you can tell them apart. This is another kind of gotcha here, which is that if you want to make sure that a given service is actually spanning your whole cluster setup the way you presumably want it to, you have to have a federated service for that thing. So sometimes having independent workloads with the same name in each cluster might be what you want. So we have that capability. In many cases, it will not be what you want. And so we will do this by turning color 2 into a federated service as well. And we will do that again in both clusters. We can now see that there's a color 2 federated. And I think that in a later version, in some future version of Linkerd, I think we are likely to make that -federated configurable, which would be kind of nice.
Yes.
So
Which I have
now,
feelings about that, because I feel like if you give people the power, they may, have the same name, get confused, but it's nice to have options, but it's like, with great power comes great responsibility and coordination and
yeah, it's the sort of
organization.
thing. It's the sort of thing where I can easily imagine situations where it would be very useful, and I can also easily imagine situations where it would be really confusing. So we'll end up playing a little bit with some of the operational side of this. All right, but here what we're doing is we're swapping color 2 to color 2 federated in our gRPC route. And if we apply that in the East cluster, that's not the one we're showing. Now it is. But you can see, oh, hey, now we're getting some red in there because it gets to cross. And if we apply it in the West cluster, again, exactly the same route. Once again, we start getting mixed results. If I turn off color 2 in the East cluster, we'll get all red. We're looking at the West cluster. Now we're looking at the East cluster. They are both all red. And if, for the fun of it, I want to go and scale them back, I can bring color 2 back in the East cluster, and then I can take it away from the West cluster, and now everybody gets the yellow version from the East cluster. So once again, we get to see that our federated service is acting like a service. And I'm kind of hammering on that a lot because it's simple enough that people don't believe it all the time, I guess is the right way to put it. But yeah, they pretty much act like services, which is really nice. Now, another place where you might be interested in things is that unhappy workloads are not always just going to vanish. You might have something that fails a lot. Here we will make the East face workload that should be returning a grinning face. We're going to make it return a cursing face 30% of the time. I would leave it as an exercise to the user to figure out what 30% of 16 is and see how close we're coming. But yeah, so that's errors. And we would probably like to deal with this with retries, right? So the way that you enable retries with Linkerd is by putting an annotation on your service. Fun fact about federated services in 2.18, they will mirror annotations from the member services. So if you annotate the federated service with the retry annotation, it'll work briefly, and then it'll get overwritten by the mirroring. So instead, we will annotate the underlying smiley service. And pretty much as soon as we do that, then there you go. Everything is happy in the East cluster. Okay, everything is mostly happy. I limited it to 3 retries. If we get really unlucky, then we'll see some sneak through. In the West cluster, things are not happy. And the reason is that retries, like routing, happen at the point of origination. So we need to make sure that the West cluster's face workload also knows that it needs to be doing retries. And right now, the annotation mirroring will not cross a cluster boundary. So we have to annotate the smiley service in the West cluster as well, so that the West cluster can see that. And now everything is happy. The moral of the story really is that if you are messing with routing in multi-cluster situations, you are going to need to be aware of the fact that if you have requests originating from multiple clusters, you need the routing logic in your multiple clusters. In a lot of situations, this doesn't really happen. In a lot of situations, you'll see a client in only one cluster talking to a workload in multiple clusters, and then you will only need the routing logic in the one place. We're deliberately making this a little hard on ourselves by having both things go both directions. Everything, everywhere, all at whatever. Another thing to remember about federated services is when you start talking about authorization policy, this is another place where you have to be aware of what's in which cluster, right? So here is a policy that will deny traffic going to the smiley workload unless it is coming from a service account called face in the faces namespace. That's the only one that will be allowed. So we have a server which is basically taking all of the pods that are marked with this label on the HTTP port, and by default, it will deny access to them. We have a mesh TLS authentication that will match only the service account named face in the faces namespace. And we have an auth policy that requires our face auth in mesh TLS authentication in order to talk to the smiley HTTP server. If we apply that, it will break things because right now the face workload is using the default service account, not its own service account. Linkerd identity is a really cool command. There I'm just grepping out subject CN to get the name of the identity that it is using. If you run it without the grep, you'll see the entire certificate that it's using. That can be really useful as well. If we create our face service account, and you have to create it before you can apply mesh TLS auth and things like that. If we create that and then we apply the policy, we should see all of our faces go to hell in a handbasket. Interesting thing here. This shuts down access in both clusters. I'm looking at the West cluster right now. In the East cluster, it looks exactly the same. The reason for that is that authorization happens at the point the request is received, because it has to, right? If you do authorization at the point where you send the request, a malicious client could just go bypass it, and that would be bad. Instead, you do it at the point that the request is received. In this particular case, all of our smiley traffic comes to the East cluster because we don't have any smiley workloads running in the West cluster. We scaled them down. So this is the only place we need to do that. If we switch the face workload in the East cluster to use the correct thing, we have to wait for this to restart. And now everything is happy again, at least from the East cluster. If we flip back to the West cluster, still nothing is working. And the reason is that service accounts are cluster specific, right? So the fact that we changed our client workload in the East cluster to do the right thing does not mean we changed it in the West cluster. So we'll do that over here. We create a face service account. We can switch the face workload to use that service account over in the West cluster. And once it's done, everything is happy from the West cluster as well. Note that we did not have to put in any auth policies or anything like that in the West cluster because that's not where the workload is living, at least not right now. One final point here. The match in the mesh TLS authentication is a string match. So for example, if we did not have a face workload in the East cluster and we just had the Smiley workload, we wouldn't actually need to create the service account. We could just go and match on the string because that's what we trust the mesh for. Part of it is we can know that if the proxy got something that claims to be using the identity face.faces.service account.cluster.linkerd.cluster.local, then we know that Linkerd already went and validated all the TLS certificate chain so we can trust it, which is a big win of using a mesh. And there we go.
Like
that is
configured for like zero trust and stuff as well. That's
a
conversation I've been having a lot lately.
Yeah. So that's the Whirlwind tour. We could go further down all the various rabbit holes, but that's kind of it, really. So on that note, let's go back and talk a little bit about gotchas further. The biggest gotcha, routing happens where the request is made, like we showed. There is exactly one routing decision that happens for the entire request. Again, this is not just a Linkerd thing. This is a gateway API thing. This is an example of what we tend to refer to in Linkerd land as outbound policy gets made by the outbound proxy. If you look at this in this world where we've got an application with its Linkerd proxy going over and talking through the proxy to another application pod, we, in a fit of originality, call the proxy that is making the request the outbound proxy and the proxy that is receiving the request the inbound proxy. Outbound policy, routing, retries, circuit breakers, funky load balancing things, all of that happens at the outbound proxy because it has to. You can't do retries effectively at the inbound proxy. Authorization happens where the request is received. Inbound policy, like auth, happens at the inbound proxy. And honestly, that's kind of it for the gotchas. If you remember those bits, you're going to be in pretty good shape. Phil, you think anything that comes to mind from you?
As far as gotchas?
Well, just in general, we're kind of at the end, believe it or not.
The one thing that comes to mind is kind of like how Federated, like how people would do this before. And I know I talked in a lightning talk on this. You know, to achieve this before, we would use things like purely HTTP routes or gRPC routes within Gateway API. But as some may know, let's say if you have a service goes down as intended, those would start throwing 503 service unavailables. So
in fact, Gateway API requires that if the backend goes down, you still have to keep trying it, and it has to give you a 5xx, because if you do it differently, then progressive delivery is in a world of hurt.
Mm-hmm. So this is where like Federated services shines, where it's like, hey, you could lose a whole cluster or services within cluster, and your other services continue to work as expected because it's just looking for endpoints like any other service would be, like that you have explained, and I think hammered the point home many times.
Yeah, it's actually fascinating that none of what I was showing for failover stuff, all that stuff where I was doing where, suppose we just scale this down to 0 and it keeps working. If you try to do that with HTTP routes or gRPC routes, it won't keep working. Full stop. So
as expected.
Yeah, and that's how it's defined. But a huge amount of this demo just fails if you're not doing something like federated services. And again, Gateway API did that deliberately because the progressive delivery case fails so miserably without it. That is a thing that Gateway API is going to have to wrestle with at some point. It's going to be interesting.
On the Linkerd side, we could help with that with like retries, timeouts, things like that. But the mindset of it should just work is a lot easier than having to configure a lot of that stuff. So
Yeah.
a lot of the motivation behind federated services.
Yep. Yeah, I actually, if I'd set this up with 3 clusters, I could have included in the demo just deleting one of the clusters entirely. So I might modify this demo for that. That would be fun.
Yeah, just for fun, or make the wrong move in your home lab and just watch all your clusters delete like I've done.
Well, yeah, I could. I would like it to be a little bit more controllable for the demo, I think.
And not have to rebuild a whole home lab. Yes.
Yeah, just say it. Yeah.
We had one comment that kind of wanted me to kind of elaborate on how, what's being migrated from one cloud provider. And I can paint a high level picture of that as, they're moving from one cloud provider where they may have just one cluster or a handful of clusters. And they have a private link between these 2 cloud providers with all the necessary routing to be able to achieve pod-to-pod routing between one cloud provider and the next. And in this new cloud provider, they're standing up multiple servers that have, green, blue, and kind of do things in a more proper way. Well, again, with federated services, it's just as easy as just, federating their services. And as they're migrating from cloud provider A to B, it just all comes seamless as, Flynn was demonstrating. So I know that's kind of boiling it down to being simplified, but, this is anti-complex multi-cluster. So the point of it is not to be overly complex.
Yeah. The most challenging thing that I've run across with migrating from one cloud provider to another is that, if you're setting up multiple kind or K3D clusters on your laptop, then arranging for them to have seamless peer-to-peer networking is really, really easy. And arranging for your clusters in different cloud providers to have seamless pod-to-pod networking, depending on which cloud providers are involved, could be difficult or expensive or both. But if you have that, then you can do some really amazing things.
Yeah, this is what makes this little one project fun. Is they have that. It's unique. I've only seen it a handful of times. So, and this is one where I went back to even your practical multi-cluster service mesh academy, where you had clusters using both gateway mode and flat network mode, because there are use cases for that as well, where you may not want things to talk pod to pod. You want to go through an ingress for reasons.
For reasons.
For reasons. There's always reasons, right?
There's always reasons. Wrapping up, that's a QR code that will take you to feedback for our Service Mesh Academy in general, which we would love to hear. That would be great. It won't take much more than a few minutes. Really, it won't. It's actually really, really easy. Go ahead and do it. You can also just ping me on the Linkerd Slack as Flynn or Phil Henderson. We're both in the workshops channel. That's an easy way to do things. I was using Buoyant Enterprise for Linkerd today. Check it out. It's good stuff. We have the Linkerd self-paced courses at, I believe, learn.linkerd.io. Buoyant.io/learn. Oh, we should have a caption for that.
It's, I can get it quickly.
That would be great. And the next Service Mesh Academy is basically arranging it so that you don't have to spend gobs of money in multi-zone clouds using Hazel. Oh, there we go.
Well, it's not the prettiest, but it's buoyant.io/self-paced courses, dashes between self-paced courses.
And Phil just discovered the crawl as opposed to the lower third titling.
I did it quickly, so I was learning.
And on that note, that should do it if we don't see any other questions. There's one other thing I see in the Slack about whether the multi-cluster is similar in architecture to kubefed. At a very, very high level, kind of. I mean, kubefed was archived a couple of years ago, so there's a bunch of details I don't remember exactly, but I feel like it did some things that were vaguely architecturally similar, but had a lot more trouble because it didn't have a mesh underneath that already knew how to do what it needed to do, if that makes any sense. The things that I have seen that try to do this without already having a service mesh under the hood tend to be really kind of fraught with peril.
I was only familiar with KubeFed that like helped with this, and I didn't realize it was retired. I used it at a previous past employer, so they were.
Well, what do you think? Company. You probably know better. You may know better than I do. How similar or not is it?
I think it's similar. Like you were saying and alluded to, it's, it didn't solve all the problems, like where a mesh kind of steps in and does it. Kind of like it comes down to the security thing. You're starting to like sprawl from on-prem to cloud. You kind of want those connections to be super secure with your, depending on what kind of data is going across them. So how do you do that without MTLS in a service mesh in a nice, secure way?
Yeah, it's a real challenge. We actually, we have folks who are doing multi-cluster Linkerd where the connection between the clusters actually traverses the public internet. And, you can do that. It's okay. MTLS is a good thing. If you have the option, you might want to not route it over the public network. But if you're doing something that's, especially if you're doing a cloud provider to cloud provider migration, you may not have a choice. And knowing that it works is a good thing.
The one I'm working with has a nice private link, so it's a nice private internet.
That's a good way to do that, I think. Yeah.
And then adding a service mesh on top of that, of course, gives you an extra layer of peace of mind. Yeah.
Yeah. Even there, I don't know that I would want that to. Yeah. Even there, I would rather have the service mesh involved for sure.
Always.
Yeah. All right. I think we're done then. And we did not finish up any sooner than we normally would. So
you shouldn't have said anything, right?
I really should not have, clearly. All right. Thanks much. August 14th. We'll talk about Hazel. It'll be fun. Till then, have a good time.
See ya. We'll see you next time.
Thanks for coming.